Okie doke. Let's get going. I did not do. Well, did I? I don't remember. I don't think I did anything yesterday. I spent time trying to learn where the change device function was in Unreal's source code, the engine. Because I was trying to make the thing I talked about before. You press escape to go to your settings. You go to your settings, your voice settings. Excuse me, it displays all your input devices. So this mic, the camera mic, whatever other mic that I might have that I'm forgetting. And then you can choose that. Excuse me. That way people can go in the game and use the device they want without having to go into the Windows settings to change whatever his actual device is. But that is useless. It's not well known in Unreal where you can actually change that. It's defined in one place, but I'm not sure how to actually do it. I've been trying, and the effort's just not worth it right now. It's not the juice ain't worth the squeeze, yo. It's not adhering to my new policy, which is I will create something if it needs to be created, and I will work on things if it will yield substantial improvements that are needed, that are necessary and substantial improvements. If it's some little thing to make one tiny little thing look better, okay, maybe not. But if it's one thing to handle a case just so someone doesn't have to go to the Windows settings, bro, your PC should be set up properly. That's on you. It's also on Unreal for not making it easy to swap. But okay, it's fine. It works as is. The game works. Now I'm going to work on content. Fuck the voice stuff. It works now. Cool. Void pointers. I've never seen this before. Can be pointed at objects of any data type? Really? Wow. There's an int, there's a float, and then there's a struct, and an object of the struct called s value, and we can point the void pointer at n value, f value, and s value. Whoa. Really? But we can't dereference it? So what's the point? Is it just to store an address of anything? It's like a some guy in a mall that directs you to where you need to go. He knows where all the shit is and can tell you wherever, but he can't actually walk you over there. Compared to the guy who works in the store can direct you exactly to the shirt you need to go and will walk your ass over and get the value that's there. Whereas this guy just knows, hey, it's over there, it's over there, it's over there. He won't actually go with you. Dereferencing it is illegal. It needs to be cast to another pointer type. Does that look like... What is that? I'm thinking of a function template now. Okay, so if we have int x, and then we have a pointer to void called xp, and it holds the address of x, okay. We want to print some shit. What happens if we try? It's probably going to give me an error that it can't be dereferenced. Must be a pointer to a complete type object. Now, what if I static cast this to a pointer to an int? I mean, that's the type, right? And we dereference that. Bop 0. 4. Cool. Okay. I like this. What if we'll do void print pointer value. Sure. What the fuck am I doing? Right here. Table. Okay. So I want. What are we gonna do? We're gonna do there's not really a point like this. I wanted to receive it. Well, I mean, I guess I could print the address that it holds, huh? I'll just do print pointer. Okay, so we have another int x, holds value 4. And then I'm gonna print pointer. What the fuck am I doing? I'm just pressing the wrong shit. And we'll do the address of x. And this takes a void pointer called, fuck it, pointer. And sure, maybe you do this. I guess. I don't like it. Fuck it. I'm sticking to my gut. Excuse me. Yeah, sure, I'll do this. Cool. And then in this case, there's no way to pass the type. Or, well, hold. No, alright, that's fine. Okay. Must be cast to another type. Another pointer. So in this case, if we have int 5, and then we had a void pointer that gets the address of this integer. Can't dereference void pointer right now. Rather, you can't dereference void pointer. But then, fuck. Why are we doing that? We don't have to do that. We could just, this could be trimmed up. We don't need to have 2 lines here. We may as well just say standard character output, cast it, boom, and dereference the whole thing. We don't need to do, oh, create another int pointer and then boom. If it doesn't know what it's pointing to, how do we know to cast it to? See, and that was the hard part. I was thinking that we could have another thing here, and then it's t type, and then I have to pass the thing. What if we did that? Is that a thing you can do? I don't think so. No, it's not a thing I can do. Damn. I was hoping that I could, but it's a T something. It's not. Ow. Ow. Oh wait, but can't I do that? Can't I just pair it to its value? Right? And now this is value type, and then static cast to a pointer to a T, and it's pointer. Fuck. Oh. Fuck. Hold. The point is I want the type. I don't need. Yeah, right? Boom. So the point is I pass the value, and we'll just pass it by reference too, just in case this is big. Because if this is big, let's do, for example, Yeah, let's do standard string. I mean, it doesn't, well, yeah. Boom. It works. We're passing this guy, and we could do it for any of these types. So we could do this. We could also do another. We could do int y7 print pointer address of y. We could do I'll create a class test, and it has a private data member int m. What we'll do standard string m name, and then we'll do test, and it takes a standard string reference name m name. What the fuck am I doing? And then blank constructor, or blank, oh yeah, I mean, we're just initializing it, it's fine. There's no logic in the constructor. And then we'll do standard string, well, hold, what do we want to do? Return a reference to it? Right, because the object exists, I think it's fine. Get name, const return am name, right? Hold, what are you complaining about? Oh, really? Wait, why were you complaining about? Oh, the point is, well, wait, why? In binding reference. Oh, I'm gonna just take a const reference. I guess the point is, because this guy's modifiable, we can't use const here. Okay, this is cool. All right, and then we'll overload, do some operator overloading real quick. So we'll do standard ostream reference operator insertion. It takes a standard ostream reference called output, and then we want a test on the right side, a test reference called test. We'll do out. We're going to output test get name. And really, we don't want to add that part. Cool. So this teaches this how to print test. Teach standard character output to print test. Boom. And now, cool. And now we can do a test called z, and we'll initialize it with test, and then print pointer address of z and z. Hold. Oh duh, and it also needs to return. Boom. Works with these and this and this. The point is that somehow, because if we're receiving it here, I can't dereference a void pointer to get the value it's pointing at, to get the type of the value it's pointing at. The void pointer doesn't know what type it's pointing at. So for now, it makes sense for me to just pass the value that it's pointing to by reference. That way, we can keep track of it. Why this is important? I mean, I guess it's helpful just to have kind of to have generic pointers. I guess generic's the weight carrying term here. So I don't have to, if I want to have a type of pointer that can point to a bunch of different things, well, but wouldn't it just make more sense to do this? And sure, I should have just done that earlier to make sure it's valid. But now we have 3 errors because these are wrong. Like, wouldn't it have just made more sense to do this? We have 1. These don't matter right now. Okay. Right? Seems like we may as well just use a template, and then we have our generic pointer that way, instead of having to pass the value to and use the template, because we have to use the template anyway. Excuse me. Oh god, I just threw up the smallest amount. Okay, let me check a text real quick. Bro, if you type 16M and send it to somebody, well, is this guy gonna say 16 miles away? Huh? Nobody in the world. Bro, nobody. Not 16 meters. Because duh. Nobody says 16M to be kilometers. Because duh. Nobody says 16M for month. Bro, 16M, 16 minutes. If I say it is this away, 16M away, 16 minutes away, 16 miles, okay, maybe. But that's MI. That's just the wrong abbreviation. 16 meters, M. How am I 16 meters away? There's no way. From anything. I don't know anything within 16 meters. And then the fucking mailing office for my apartment is more than 16 meters away. And then months? It's not months. It's not fucking meters. It's not fucking kilometers. Hello? Okay. So we can cast it. Okie doke. See? See, really? We're gonna be doing this? Oh, this is trash. This is terrible. So we're now passing the fucking raw value. We're not even receiving it as reference. This is garbage. And then we're doing a switch every time. I mean, I guess on my case, the compiler would have seen that there's one, it would need to generate multiple versions. But now we have to fucking do a switch and then include all of this shit. Type? Wait, really? Hold on. What is this type T int shit? Oh. Oh wait, never mind. What the fuck? Oh, this is just an enum. Hold on. This is terrible. Now when you do this, you have to put the raw T int for these. This is junk. Yeah, that makes sense, because if you do +1, and we're talking about a standard string, let's say, I don't know how big a standard string is, maybe it depends. Let's say it's fucking, say it's 16 bytes, big, or 8. Let's say 8. 8 makes more sense, I think. No, let's say 16, fuck it. And we do +1. If it's an array of standard string, or well, yeah, an array of standard strings, +1 moves 64 bytes over. Or 64 bits. What the fuck am I saying 64 bytes? And, or, 16 bytes, that's fine. 128 bits? But if you do pointer arithmetic, the pointer needs to know what type am I moving over. Or am I a pointer to an int? Okay, if you increment me, then I'm moving over 4 bytes to the right. If I'm of a short, then it's 2 bytes to the right, or 2 bytes to the left if you're subtracting, decrementing. What do we mean by deleting? Like, do we mean like this? Excuse me. So what if we said a pointer to void called pointer, and it gets a new int? Okay. So that works. Good. And then what happens if we delete it? Undefined. It doesn't say. Okay, interesting. But it seems like we would probably do delete. Well, I don't know how this works, because static cast, I thought that it would make a copy. It's not. Oh, but the point is we're still talking about the address, so it's fine. Even though if pointer copies the value, the point is that we're deleting what's being pointed to. So what we want to do is delete the static cast to an int pointer, and then pointer is null pointer. Like that. Okay. Void reference. Well, yeah, because if it's void, a reference is just a pointer. So if we say that's already dereferenced, if we can't dereference a void pointer, we can't use a void reference. So we have this integer, and then we print, and then we do that. And the point is it's saying, hey, pass in this address, and it's this type. It's a C string, C style string. And the function will output it pass to a character, or convert it to a pointer character. So if you incremented it, the math would be wrong. Excuse me. I don't know what in direction is. What is indirection? Oh, I don't have to dereference it? To a character pointer? A character pointer will be treated as a C-style string? Huh. Oh, because when we're outputting a pointer to a character, it'll just print by default the entire thing? Is that how that works, really? Need to be able to print. Hmm. No, what the fuck am I doing? Oh, shit. So it doesn't in this case? Why? Because it's const or something? Maybe I got lucky before. You're using const character arrays, I think, or just character arrays. They were printing fine when I was making them as literals like that. Oh! What if we did this? Yeah. This automatically maps them. Okay, that's why. I was putting the individual characters versus before I was making a string. In default, so if it's not the right type, yeah, this is just shit. So otherwise we would do 5, but then we would do this, which means we would output probably to a character pointer. So we think, oh, it prints the value for characters. If it's not a character, what's the value it's actually doing? Is it gonna convert the int to its character ASCII code and then print out that? So whatever code 5 is, which is like a space or something, I feel like that's 23. And then, yeah, I don't know. Mm-hmm. Yeah, I mean, you may as well overload and then just do the same for each. Or, well, yeah, and the generic programming is just a way of doing the simple overloading because we do the template T or template type name T, and then we just pass the one thing, and then boom, we just have a pointer that becomes the type that it needs to be. At compile time, the compiler sees, oh, hey, buddy, this function is, hey, me, this function is being called with a pointer to an int, a pointer to a character, and a pointer to a standard string. Well, that means we need 3 instantiations. One version for an int, one version for a character, one version for a standard string. But we only have to write one, and instead of passing in int, character, standard string, we just put t and have a little template clause before that is that says type name t. That way we can use t, and it will deduce t from the constructor calls. Or rather, not from the constructor call, but from the function call. Boom. Template. Oh. The difference between a void pointer and a null pointer? Bro. Any pointer can be a null pointer. A void pointer is specifically a pointer that can point to any data type and cannot be dereferenced because that is illegal. Whereas any other type can point to its type only, and it can be dereferenced to get that value if it's actually holding an address. And any of those can hold null pointer. So null pointer is simply any pointer that is holding the value of null pointer, which can be all null pointers, or which can be all pointers. Any pointer can be null pointer, but only void pointers are void pointers, and they can hold the address of any type of object, including no object, null pointer. Oh, true. And if we want to dereference the void pointer, then we need to cast it to be the type of pointer of the data that we're actually going to be getting the value of. Yep. To perform indirection. Indirection is the dereferencing. Yep. Yep. Ooh, this is fucking long. Here we go. Time to learn. A pointer is a variable that holds the address. So if I dereference it, what? Does that mean I can call it? How does that work? Let's find out. Well, I don't, but how would I, what if we did this? Void test, and then I had an auto pointer called pointer, and it holds the address of test. Oh shit, we can do that. And then what if we dereference test? Oh shit, really? Whoa. Never mind. Oh wait, what the fuck am I doing? Oh shit. Oh wow. So I can have a pointer that holds the address of a function, and I can dereference that pointer to get the function, and then give that function arguments, pass it arguments through via the pointer. Holy cow. Wow, okay. What if we have a function or a class with a private data member? And it has a public data, or a private member function, and it has a public member function that returns the address of the private member function, and then I call that from somewhere else. I call that from the public. Don't know. Let's find out. Okay, this is interesting and kind of, yeah, it's surprising. So we'll have class test, and we'll have a private member function and a public member function, and we'll say, excuse me, void private test, excuse me, oh, I gotta go to the bathroom soon. Oh, okay. Void, or and then this is, I don't even know, an auto pointer, a pointer toward something called get private test, and it's const, and it returns the address of private test. You kidding me? What if it was auto? Oh, here we go. Yeah, because auto, it doesn't need to be auto pointer. Auto pointer, auto's already finding it, and it's already being the pointer to this function. I don't know. Okay, that was just a syntax error. Whoops. Just like forgetting a semicolon. Okay, and now I create, well, let's see, what do we want? What happens if I make it static? Uh-oh. Well, it's no const because there aren't any data members yeah, no data members. So, what if I will hold, if I do test, we only get private test because it's public. But what if I get private test, okay? And that yields a pointer to this guy, and then I dereference him, huh? What do you mean missing an argument list? Huh? Oh. Wait. Hold. If I have test, get private test. Evaluates to a function that is missing an argument list? Yeah, so. Oh. So we're doing this. And then we're putting the entire thing in parentheses and then calling it. Holy shit. So we can break encapsulation and don't want to do this, but I just wanted to test. We can have, wow, public member function that yields the address of a private member function because functions have addresses, noted. And I can dereference that address to get the function and put the whole thing in parentheses. And then I can put the parentheses to call the function. Holy cowser. Okay. That is interesting. I'm going to go to the bathroom because I got to go soon.